We're actually starting on time.
Okay, yeah.
And I didn't prepare a title screen today.
Oh.
We're
My
on.
mistake. I know.
Okay.
Welcome everyone. This is another episode of On.NET, and we have a crowded studio today. So we're with Rowan Miller from
morning.
Entity Framework. Hi, thanks for being on the show.
Pleasure to be here.
And we have Rich.
Yeah. I'm back after about a month of absence.
Yeah, it's been a while.
Yeah.
And as usual, we have Kendra in the studio. And as usual, we are taking questions from the audience. So if you want to send us your questions on Twitter using the hashtag onnet, pound ONNET, or on Gitter /.net/home, same hashtag, please do. So, hi Rowan. So for people who don't know you, you are in charge of Entity Framework.
Yeah, I work as the program manager for the Entity Framework team, which means I make sure all the trains run on time and fill in all the gaps that need filling in. Make sure we ship a good product.
And talk to customers, I assume, once in a while.
Once in a while, yeah, that helps with shipping the good product. thing,
Yes.
so, yeah.
Okay.
Yeah.
So today specifically, we are going to talk about Entity Framework Core, which is a different thing from Entity Framework, and we should probably explain what the differences are.
Yep.
And even more specifically, we're going to talk about 1.1, which
Mhm.
is the next version.
Yeah, so we actually caught up a while back, or me and Richard did, and we talked about EF Core and we did some demos on 1.0. So if folks want a detailed overview of what EF Core is, going back to watch that show would be a good place to start. We'll briefly go over it today, but we spent a good hour digging into it and looking at code and seeing exactly what EF Core is. Like you said, we're close to 1.1, so we're going to particularly demo that release
Yeah.
today.
And the show on the first show where we had you was very, very successful. It's actually the one where we got the most views. So
Oh, very
people
good.
are definitely interested in that topic. And
So we set a high bar then.
They've enjoyed that first show, so let's do it again.
Yeah, I also can say I've seen Rowan present in other venues. Like, he's definitely one of the folks we send to conferences a bunch, and those are always super well attended.
Yeah.
So it's a popular topic for sure.
Yep. All right. Thought we'd start by kind of setting up where we're at with EF. So we're on my screen. I assume you can click a button for that, Bertrand.
So Kendra is going. Are
Alright,
we
can
actually
we-
live?
Yes, I'm alive.
All right. If we can bring up my screen so that
Uh,
folks can see it, that would be great.
Oh, yeah. Sorry.
All right,
It's
very
on your
good.
screen.
All right. So what you're seeing is where we're at with EF today. So on the left-hand side of the screen, you can see what we refer to as EF 6.x, which is our current set of Entity Framework releases. Goes all the way back to 2008. We're not going to go into super much detail about how we ship them, which is kind of what's in the middle of the screen. But with our latest releases of Entity Framework 6.x, everything is out of band. On NuGet, Microsoft Download Center, and we chain the latest versions of those into Visual Studio when we ship. Entity Framework Core 1.0 has been out for a little while now, and it follows the same model. But the important takeaway from this slide is that it's in a separate column. It's a separate train. And so we have both of these trains continuing to go forwards in the future. And then to kind of reinforce that, when we look at the releases we're working on at the moment, we have Entity Framework Core 1.1 and we have Entity Framework 6.2, which are two patch releases or minor releases that our team is working on concurrently. So the big takeaway from this screen is we have two trains of EF. They're both valid. We're both continuing updates to them.
Right. So from a engineering team standpoint, you've got a kind of a code development plan. Can you talk a little bit about as you come up with some new concept,
Yep.
how you decide what to put in regular EF, I'm not sure actually what the name is, and EF Core. And just as an example, that would be the one that would be top of mind for me would actually be NoSQL databases.
Yeah. So something that's not relational is going to just be in EF Core. So EF6 has been around for, like we said, a long time. The code base existed long before it first RTM'd in 2008. It's very difficult to drive major innovation in it because it's monolithic. It's kind of like a big plate of spaghetti. You move one noodle, meatball falls off the side and everything breaks, and it takes a long time to stabilize. EF Core we've built from the ground up to make it easy to innovate in. Very modular, under the covers. We'll actually look at that in some demos today. So big innovation is going to happen in EF Core. Small improvements community contributions and bug fixes will happen in what we're referring to as EF 6.x, which is actually important. So because we're calling it EF6, I think that kind of helps reinforce that we're not anticipating doing another major release. We expect to stick with 6.2, 6.3, 6.3.1, but we never anticipate going across to a 7 with big new features in it.
I see. So from a product standpoint, you kind of, it's more like left brain, right brain, like in terms of how you think about evolving these forward. It's not like you say, oh, here's this thing we're going to do. Should we put it in both or just one? It's typically continue improving EF6 in terms of EF6.
Yep.
And then EF Core is really where the forward-looking innovation,
Absolutely.
new features, and new scenarios go.
And that's actually, if you were looking at the two and trying to work out which one you should use, you could think of them as EF6 is the stable one that we've been releasing and patching and stabilizing and improving for 8 years now. EF Core is brand new. Like we haven't even done our first minor release on it yet. We've had one patch of it. So it doesn't have all the features that a full-featured ORM would have. And we need to spend time stabilizing and improving it, and over time it will take over from EF6, but at the moment it's not the stable battle-tested thing.
Makes sense. So a question along those lines is, I assume there's, thousands, millions, I don't know what the number is, of people who are using EF6 in production. Do you have customers that you're talking to right now that are using EF Core in production and presumably having success?
Yes. Now I would say we are trying to be extremely cautious with the guidance we give people because we want to set very realistic expectations. So obviously if you adopt a V1 product, there are going to be some rough edges in it. And so we try to set that up front. But the folks that we work with have been successful with it once you're aware of the limitations of it. That makes sense. One of the biggest areas we see is performance. The performance that you get out of EF Core compared to EF6 is significant. We actually looked at that when we sat down and talked. We saw, 2 times, 3 times, even 4 times throughput on EF Core compared to EF6.
Right. So what I'm hearing from you is the production aspect is less a concern around stability and performance, and just more in terms of feature scope. Is that correct?
Yeah, and I think that becomes more and more the case. So our V1 release, the link provider, which is the thing that takes your link queries and translates them to, in the case of a relational database, SQL, that is by far the most complicated part of the stack. And I would say when we released V1.0, it was the least mature area of the stack. We released a patch, 1.01, which improved that a lot. And then our upcoming 1.1 release, we've done a lot of work to improve the link translator.
Right.
Which would be the biggest pain point that people hit using 1.0.
Yeah, actually, I think, so I sit through our, I don't think we've really talked about this before, but I ship through our .NET Core ship room, war room. We have different names for that. And I think when we did our 1.01 release, a fairly significant portion of the fixes were actually from EF.
Yeah.
So that actually agrees with what you just said.
Yeah, absolutely. And almost all of those fixes, I think there was around about 15 in there.
Yeah, something like that.
All but a few of them were in the query pipeline.
Yep. Okay, so that's awesome.
So I think if I had to contrast the two, EF Core is new and it has a lot of benefits in it. EF6 is battle tested and has been around for 8 years. So.
Right. So certainly if there are customers who are still using 1.0.0, I'm guessing you would highly recommend them to move to 1.0.1 for EF Core.
Yeah, absolutely.
Yeah.
And then you should definitely look at adopting 1.1 as well.
Yeah, when that comes out.
Okay. The one slide I like to just reinforce everything that we talked about. So this is the slide that Scott Hunter and various folks have used to describe the world of .NET at the moment.
Yeah, we love this slide.
Okay, so when we look at how EF fits in this, EF 6.x fits in down the bottom in runtime components, but it wasn't built with this whole world in mind. So we lose .NET Core, we lose Xamarin, we just work on .NET Framework. So WPF, WinForms, all of those things. We are very much compiled specifically against the .NET Framework. .NET 4.5.1 is our, or 4.5 is our kind of baseline that we compile against.
That's your min.
Yes. When we look at EF Core was built with this whole ecosystem in mind. And so EF Core lights up everywhere. Now, I do just want to clarify this is what we're working towards. We have a few areas where this vision isn't quite reality yet. So UWP, we have a few rough edges, particularly around compiling with .NET Native. So we're working with the .NET Native team to iron out those issues at the moment. And then Xamarin is lighting up with .NET Standard Library support, which is what EF is based on. but that's not 100% yet, and so we're still ironing out some rough edges with Entity Framework Core in Xamarin as well.
Makes sense.
Yep. Okay.
Awesome. I do have another question that just occurred to me.
Go for it.
Last time we had you on the show, we talked about how EF is not the only ORM
Mm-hmm.
in the .NET space, and
Or even in the .NET Core space.
yes, sorry, I just meant within the .NET ecosystem generally,
Yeah.
but that's a good comment. There are other ones that have done the work to port to .NET Core and are
Docker,
available.
for example.
Yeah. So that relates to my question, which is, I don't think we have to like completely go through that whole conversation again, although we can certainly address some of it.
Mm-hmm.
My real question is you kind of made this big transition between EF and EF Core, and the two things that I think are the most interesting are this kind of monolithic to modular, and then supporting different types of databases, databases in air quotes,
Yeah.
for this one. Do you know if any of the other ORMs have kind of made similar transitions, or did they already say support NoSQL as well before?
So I don't think any of I think most of the major ORMs were built with the idea of relational in mind. Some of them have been retrofitted, and that's usually done at the provider layer. So actually, even for EF6, you can get some providers that work with certain non-relational data stores. But the whole stack, they're kind of jimmied in because the whole stack is built with relational in mind.
Right.
I think now, I've often heard, well, not often, I would say it's kind of a new idea that people are playing with, the idea of having a top-level API that works across most data stores without being super magical and trying to hide the type of data store.
Mm-hmm.
I've seen that sometimes referred to as an OXM instead of an ORM because it's object to whatever database you're mapping to. Mapper.
Yes, I actually forgot when we were talking about this what the R stood for. Yes, it's
Yeah.
quite specific, isn't it?
It is, yeah. So we still refer to Entity Framework as an object relational mapper or an ORM, but in reality, the relational aspects of it are buried down in the relational-based provider.
Makes sense. I have another question.
Go for it.
Now we're even getting further afield. We were talking to we had a customer come visit us just recently, and this week, and so one of the guys there was talking about how they have this data store, and when he was describing the characteristics to us, it actually sounded like it was more of a NoSQL type of workload, and all the people on his team were actually telling him about that as well. And you know, he clearly grew up in the relational kind of time and mindset, and he wasn't quite ready to give up on relational and all the good things that come with relational. So maybe you could speak a little bit to that, about kind of both that transition for folks and how you kind of choose whether a certain kind of workload or data type should go in relational or kind of NoSQL/document database.
So we could probably spend a whole session talking about this in particular. So the transition part in particular, most data stores that we would think about accessing as a .NET developer have a .NET library on top of them. And so to that extent, we can write .NET code to interact with them. What we're trying to address with EF Core in particular is the idea that I can use very common coding patterns to access. Now, we don't hide everything. So if you target, say, Azure Table Storage, we don't hide the fact that Azure Table Storage requires a two-part key, a Rowan partition key.
Totally.
So you have to be specific about that. But if you're learning those new concepts with an API that you're familiar with, so you'd still use the Fluent API or data annotations to go and say, this is the row key, this is the partition key, then it takes down some of the barriers. I don't have to go and learn a whole new SDK at the same time. One caveat I put in there is we're not trying to replace SDKs. It's fine. If you want to go and access Azure Table Storage, we're not trying to move folks away from using the native SDK for accessing Azure Table Storage with .NET. Folks that want to use something like Entity Framework, it's an option for them. And then in terms of what data belongs where, I think it's always a blurred line, right? Nothing is 100% locked into a particular data store. You know, SQL Server doesn't necessarily really support unstructured data, but you can always get around it with, you know, JSON columns or XML columns that hold data that doesn't necessarily fit into a column type format. To the same extent, when folks use non-relational stores, sometimes they end up trying to model relational concepts in a non-relational store, like having a value that's used to look up the primary key of from another table, if you will, in that store, you're basically modeling a foreign key constraint. It's just not enforced by the database. So,
and the engine is not optimized around it usually.
yeah, absolutely. So I'd say it's a very deep concept. I think when you would think about moving is when your data store is starting to limit what you can do with your data. So if you're finding that everything is so unstructured that you're having a real hard time with columns and tables, then maybe it's time to think about something that's not a relational database. Conversely, if you're trying to retrofit a whole bunch of relational capabilities into a Redis cache, then maybe it's time to think about a relational database for storing that data.
Right.
Yeah. That's a very open-ended answer
It
to the
is.
question because it's a very open-ended problem.
Right, and one that just doesn't have super concrete guidance.
Yeah.
It's so domain and application specific.
Yeah, and to be honest, like you could be very successful with two completely different data stores for the same problem. You're just going to have different limitations that you start to bump into and different strengths of that data store. So I think it's about getting educated about the options that are there, and especially when you hit things where you're like, the data store is not really doing what I need it to do to make this performant and efficient way for my application to run, then that's time to start looking for a different data store.
Totally.
Do you think there is a taste aspect to it as well?
Oh yeah, for sure. It's like the arguments between different programming languages and different data stores, a lot of it comes down to preference, right? And actually we even see that with Entity Framework. Whether I use a full-blown ORM or not, to some extent you can be very successful with an ORM and you can be very successful working with ADO.NET. It's partly comes down to taste. Does my team like to write SQL queries and work with data readers? Does my team like to write objects and work with link queries? There are advantages and disadvantages to both, and a lot of that is taste.
Yeah, and that's why we need options.
Exactly,
Yes.
yeah. Yep,
Yes.
I've always said EF is a tool in the belt that you have, and if you're successful with it, great, and if you're successful with something else, my high-level bit is that folks are successful with data on .NET, and if something else gives you that, great. We want to be one option.
Maybe we can just pause for a minute on the Azure table example.
Mm-hmm.
I've used that a fair bit. Actually, not with EF, just directly.
Yep.
And so one of the questions that comes to mind is with Azure Table, and I assume this is very similar for other kind of document-oriented databases, is you have to like think quite a bit up front about how you're going to use the primary key and the row key, and so you end up kind of having these kind of multi-part pieces of data. You know, maybe you've got hyphens or underscores between the different segments, and then you do these semantic oriented queries. You kind of do greater than or less than to kind of constrain the data space, if you will.
Yep.
As the query to say, these are the rows I want back. When I'm using, and so you definitely absolutely have that control when you're using Azure Table API, and you have this kind of query-oriented thing, the set of objects that you have to build up. Not a super fan of how that works, but do you have something similar? Would it be a similar experience in terms of that kind of data space description, the semantic querying with EF?
So I just want to add in one caveat here. So at the moment with RTM of V1, the only providers that are RTM'd are our relational providers. So while we're talking about all these things, so we have prototypes for Azure Table Storage and Redis. So these things will be a reality in RTM format, but they're not quite yet. And then we're also in talks with someone who's looking at writing a document DB provider. So these things are coming in the pipeline. I just want folks to know that you can't go download and use this stuff in RTM format at the moment. But to answer your question with the provider that we have prototyped at the moment, actually the Azure Table Storage one, we got well beyond a prototype. We started getting it ready for RTM, but then just had to put it to the side to focus on getting the rest of the stack RTM'd.
Totally.
In that particular one, we still write link, but we're very clever, we are very selective about what gets sent to the database and what gets evaluated in memory. So in particular, queries that use the Rowan partition key, those things need to be sent to the database, and that work against the Rowan partition key needs to be done in the database. Other things can be very inefficient to do in Azure Table Storage, and some of those can be handled efficiently on the client side. And then if we're hitting a case where executing your query is dragging large amounts of data into memory that is then getting thrown away, then we start to issue warnings saying, we can evaluate this query, but it's not going to be efficient because the data store we're targeting doesn't have an efficient way to run this query. Does that make sense? So we try to provide a good abstraction, but at the same time we try to warn you when that abstraction is leading you down a dangerous path. which is easy to do
Makes
when
sense.
you're accessing a database and that doesn't have a whole bunch of native query capabilities, and you're trying to filter by stuff that would be a full table scan and pull a whole bunch of data back into memory. It's not a successful path to go down.
It's interesting to hear you use the term database because like when I think of Azure Table,
Mm-hmm.
I think of it in terms of a service.
Yep.
You know, you don't talk, like the database itself is like very kind of opaque to you. Like
Yep.
there's definitely a level of abstraction, which is kind of the REST service.
Yep.
So I assume with not ADO.NET, EF Core with the Azure Table provider, you're still just talking to the service. You don't have some special arrangement with a database.
No, we go straight to the REST service.
Yeah.
So originally when we prototyped the provider, we built it on top of their existing .NET SDK.
Mm-hmm.
But then in the end, we found that the best way to map these things was to go directly to the REST service. So that's how our provider works. The one thing I'd add, obviously, the term database, we're using it quite loosely.
Mm-hmm.
We started using the term data store with our stack. So off DB context, there's a .database property that was originally called data store. But we found that everybody, us and customers included, just kept referring it to as the database because it's more of an EF terminology, I guess, that we've adopted to mean the thing that you're connecting to that has the data in it. So we use the term quite loosely on our team and in our API as well.
Yeah, totally. I guess I also said the wrong thing. I referred to Azure Table as a document database. It's actually a NoSQL database, right?
Yeah, and again, that's if you look up the definitions of NoSQL, they're varied and fuzzy at best.
Yeah.
So, I also like the term non-relational. That tends to be how we refer to our providers. So at least from the EF perspective, obviously relational is our bread and butter. And so our relational providers build on the ADO.NET providers. And so we class those as the relational providers. And then the other things that we're building that don't fit into that mold, we tend to refer to as non-relational.
Yeah. Yeah.
Should we start
Yeah,
talking
let's-
about 1.1?
Yeah.
Okay.
let's. Absolutely.
Because Rich will just keep on talking.
We can answer questions all day, that's fine too. So EF Core 1.1, it's coming out soon, later this year. The main focus for our team has been on bug fixing. Obviously a V1 product, you don't get to fix every bug before you ship, so we're focused on that. We have fixed a lot of bugs. I can't remember the exact count off the top of my head, but I'm sure it's over 100 by now, bugs in that release. We're also adding back some of the critical ORM features that weren't present in V1. So I'll go to my next slide. So we're not going to talk through all the points on here, but this is just a list of stuff that is in 1.1. This ticks off some of the pain points that people have where they come to EF Core and say, I really need this feature and it's just not implemented yet. It's not everything, but it's a good start. And our releases will continue to look like this for the next little bit, probably for the next year. It will be all about adding in our kind of bread and butter ORM or data access features into our stack. And then I did want to pop up a few that people always ask about. So complex and value types is the idea of instead of just having properties directly on my entity, like address line 1, address line 2, I can group those properties into an address object. And so an order has an address and a customer has an address. We don't have support for that yet, but we are working on it, but it's not quite going to make it into the 1.1 release. And that's the same story when we look at simple type conversions. Like I have JSON property in my entity, and I want to just put that in a varchar max column in the database because that's how my schema is. So simple type conversions like that. And then at the moment, EF is in Visual Studio, but there's not much visual about EF at the moment. All of our tooling is command line. You can run it from Package Manager console, so you don't have to drop completely out of Visual Studio. But we're looking at adding in graphical wizards and things to help you work with EF Core. The first one that we'll work on will be a wizard to help you reverse engineer a model from an existing database, which is entirely possible today. You just have to use a command line style tool to do so.
Makes sense.
Okay.
On your both bug fixes and new features that you're adding, can you give us a sense on percentage or something else on ones that you kind of found and came up with yourself versus customer reported and requested?
Yeah, I would actually, I'm going off my cuff here, but just based on, so when issues come in, whether they're logged from our team or from the community, we sit down and triage those regularly each week. And so I touch every issue as it comes in and we decide where it's going to go and who's going to fix it, when it's going to get fixed. So my gut feel is that at least half of them are customer reported issues, possibly even more than that. It might be more like 60-40. So there's a lot of customer reported issues in there, which is actually an approach we've taken. So if we think about testing our query pipeline, in EF6 we took a very academic approach to that. We looked at, can I do model-based testing? Can I generate every possible link expression and run that and make sure it executes correctly in the database? In EF Core, we've tried to be much more pragmatic and said, let's focus on the real customer scenarios. Let's look at things that people actually write in link. And let's try and pad out, as a priority, let's pad out the areas where customers are actually using this. And part of that is responding to feedback. We see a class of issues come in, we're like, that is an area of the stack that we need to go fix because a lot of customers are hitting these issues.
Do you do anything to steer the user to the pit of success? Anything that would avoid, select N+1 programs or stuff like that?
Yeah, so we have logging built into EF Core, and it's the same logging that's used in ASP.NET Core and hopefully other places in the future as well. Anytime we do something that we think is inefficient, we write a warning to that log to tell people. So this would be if we're pulling excessive data from the database and doing evaluation in memory. And actually we write a warning anytime we do any part of the query, doesn't get sent to the database to be executed. We write a warning and say, this is something you might want to go look at because there may be a more efficient way to do this in the database.
Nice.
Yeah.
Nice. So you say you write a warning. You probably said this, but where does that get written to?
So it gets written to logging, which is a kind of generic concept baked into EF and ASP.NET Core. And you can hook up to that thing and basically write it any way you want to. So you add in your own implementation of logger, or if you just want to write to, say, a console, there's already a baked-in console logger that you can hook up.
I see. So are there examples somewhere on how to do that?
Our documentation is docs.efproject.net.
Okay.
And there's a section there dedicated to logging, which will just give you the simple code you need to write to get it working.
That sounds quite useful.
It is very useful, yeah. And if you're writing an ASP.NET Core application, it's hooked up by default, so it'll go wherever the rest of your ASP.NET Core logs are going. If you're writing WPF or UWP or something like that, then you would just hook it up to go to a file or the console or wherever you want to have that written. Okay, should we write some code?
Yeah.
Cool.
First thing I wanted to do was look at a simple new feature that we've added in 1.1, which is field mapping. So if I scroll down to the bottom of my screen here, I have an entity, which is my blog that I want to save to the database. And I have a URL property here, but what you'll notice about this URL property is that it has no setter on it. I have a getter so I can get the URL back, but I don't want folks to say URL equals when they update it. I want my application code to go through this set URL property. And the reason it's, through the set URL method. And the reason it's a method is because this does some fairly heavy work to validate. In fact, I've actually got it going off and sending off a web request to make sure we don't get a 404 from the new URL or something. Realize I'll turn my screen a little so maybe you can see it, Richard. Now, generally accepted that folks shouldn't write code like this in a property setter. We expect property setters to be quick and always succeed and things like that.
Yep.
Now, what's interesting in EF6 and the first release of EF Core, this model wouldn't work with EF because EF insists on having property getters and setters. In 1.1, we've added the ability to map to a field. And you'll see that I have the underscore URL field in my blog class here. Now, by default, EF will only pick up a property if it has a getter and a setter on it. The setter doesn't necessarily have to be public, it could be private, but we need to have a getter and setter by default to include the property in the model. Here I have my context, and the way that I do configuration for the model is to override on model creating, and I can write code in here to further configure the model. So I'm going to pull up the model builder, and I'm going to pull up the configuration for blog, and then I'm going to say there's a property called URL. So now I'm pulling up the configuration for URL. That's actually all I would have to write because EF has some conventions to say, okay, you want to map the URL property. Let me go see if I can find a field for it because it doesn't have a setter. And so underscore property name is one of the conventions that we would pick up to work it out. Let's say I'm not following the conventions. Let's rename this to something else. Let's call it the URL.
Right. So no longer guessable.
Yep. So now EF would throw, if we ran the application now, we get an exception saying no backing field discovered for property URL. At this point, we can use the hasField method to tell it what the field is.
But you didn't have a property, did you?
At the moment, I have a property with just a getter.
Oh, right.
In a second, we'll look at having no property at all. Okay. So I can still, use a lambda here to refer to it because in my class, I have a property with a getter and then a method for the setter. if I scroll up to the top, you just see I'm creating an instance of my context. The setup database method is just making sure the database exists in the background for me. I create an instance of my blog. You'll notice that I can't set the URL property, so I'm using the set URL method that we talked about. I add that blog to the context and call save changes, and then I fetch back all blogs from the database ordered by the URL property that we just had. If I go run this code, the main thing we'll see is that the application succeeds. And then if we go look at my database, so I've got it hooked up to LocalDB, so I'm just going to refresh my databases. So I'll see the field mapping. If we go look at blogs, we'll see that the URL column is there and populated. Actually, let's just select from it to show that it's populated. So we can see that URL is getting in and out of the database successfully. Let's go one step further. So you mentioned the idea, what if I don't have a property at all? So let's change this to be called getURL and make it a method. We'll just do a bit of cleanup here to make that compile. Okay, so we have a get and a set method, which is not an uncommon pattern in objects, and I want to persist this data to the database. I can't write this code anymore because there is no property to map to. Now, I can just shorten it up and do this. And EF is smart enough to know if I can't find a property called underscore the URL, then I'll go and see if I can find a field called underscore the URL instead. The problem with what I've done here is now this property that's part of my model, and I use the term property loosely here. It's conceptually a property that this entity has in our model, at least in our metadata. It's called underscore the URL, which means that's what the column in the database is going to be called. And anytime I wanted to work with metadata, I'm going to see underscore the URL, which probably isn't how I want to. I want this thing conceptually to be called URL. So instead of writing that code, let's go and we'll say there's a string property, which I could call anything. This name is not important, but I choose to think about this property as a URL property. So it's conceptually a property in my model, but it's mapped to the field in the background. If we scroll up, we'll see that I also had this link query where I was ordering by URL, but I can't do that anymore, which is where it's nice to have a good name for this field in the model. So I can say ef.property, similar code that I just wrote, and I can get the property called URL. And so now I can order by this conceptual property even though it's not actually a property in my model.
Right, so you're kind of going through an abstraction now.
Yeah, I'm saying order by, and I can't write this with link because it's not actually a property in my CLI class, but ef, order by that thing that I put in the model that's called URL.
Right.
Yeah, and what we're ordering by here is something that's in the database, obviously.
Yes.
So you have to tell it what in the database to look for.
Yes, absolutely. And so this property, we could actually even rename it. So the column could be called something different again. It could be called blog underscore URL in the database, and all of our mapping still works. We're basically saying this is a property in my model, but it doesn't have a corresponding property in the CLR class. Now in 1.0, we had the idea of shadow properties where you could say, conceptually there's a property in my model, but the data is not at all persisted in the CLR class. You should keep track of it separately. That's called a shadow property. This one's a little different. We're saying this is conceptually in the model, it's not in the CLR class, but the data is still stored in the CLR class, it's just not stored in a property. In our case, it's stored in a field.
Makes sense.
Okay?
So one thing I noticed,
No, I was going to say it seems to materialize the fact that, like all abstractions, there is some leakage that's going to happen at some point or other. And,
Yes.
and sure, you can actually take those into account.
Yeah, and obviously at this point, Link doesn't really have any strong ties to Entity Framework. But when I start using properties like this, the data access stack that I'm using is duly noted in my link query.
Yes.
Obviously, that's not hidden away by any means. Now, one thing we'd like to work towards in the future, and we don't have it yet, is instead of doing this, I could say order by blog.getURL, which would give me the URL, and then you'd actually have a way to tell EF when you see that getURL thing, it actually means go and look at this column.
You would
in
have
the database.
in some other place to specify what the
Yeah.
mapping is between your
Yeah.
methods
And so that's
model.
a big continuum. Is my data access stack governs exactly what my CLI classes
Yes.
look like,
Yeah.
which EF Core is pretty rigid about that in 1.0. It says you have to have properties, and those properties have to have a getter and a setter. All the way down to we can arbitrarily map any pattern to any pattern. And I would say in 1.1 we're moving the needle just a step this direction, but obviously we have a lot of improvements we can do to be more flexible about exactly what you can map.
That makes sense.
It does make sense. Yeah, one thing I noticed is it looks like you do support like pure POCO style classes.
Yep.
Yeah, for those who don't know, that stands for, at least my definition of it is plain old CLR objects.
That's mine too, so hopefully we're right.
Yes. The other definition is C# objects, which to me feels a little narrow. Like in some other systems I've used, you to participate, you're forced to have it, implement some interface or use some base class. It looks like you don't have that requirement.
Yeah, we can do plain old CLR objects, like you said. You can't just have any object. There are some limitations about, like we mentioned, properties or fields, basically, where we're at now. So you can do properties or fields for your data. But yeah, no base classes, no interfaces. You don't have to have attributes.
Virtual.
No, there's no restrictions really over the properties. They don't even really have to be public.
I'm mentioning that because in Hibernate, for example, they have to be virtual because they are using dynamic proxies.
And that's actually, so EF6 used dynamic proxies to do change tracking as well. You didn't have to have them, but things got significantly more efficient if you did have virtual on your method, so that we could dynamically at runtime create a type that derived from yours and insert a whole bunch of extra logic into the property getters and setters.
I get it. Yep.
Now in EF Core, the way that we track changes to the objects is when an object comes out of the database, when we create it based on the data, we take a snapshot of the values so that we know what the original values were. And then when it comes time to save, we can do a compare and write any changes to the database. In EF Core, that process is significantly faster and uses significantly less memory than it did in EF6. We really tuned that. But if you're working with very large data sets with lots of changes in them, or very high frequency of changes, that can get inefficient. And so we also have the ability, if you want to, you can implement iNotify property changing and changed on your object. And then instead of us taking a snapshot of the object, of the values coming from the database, we'll just listen to your events and we'll capture the values when you actually change them.
Okay.
Again, at that point, your data access stack is starting to have some influence on the shape of your objects. But as you want to get better and better performance, those are some of the, compromises you start to look at.
Makes sense.
We did also talk about attributes. So you don't have to have attributes in your class, but you can put attributes to influence how EF interprets your model. So you can put a table attribute that says this entity maps to this table. There are ways to do that, like the code that we just wrote in on-model creating, so that I don't have to have attributes, but if I want to, a lot of folks think it's easier and simpler to understand, so it's an option that you have.
That goes a bit back to the taste thing again.
Oh yeah, 100%. It's completely a taste thing. Okay, that's what I had for field mapping. We talked about EF being modular, and we talk about this as it being built over a set of services. The idea of a service being a class that has one responsibility, whether that's detecting changes in an object since it was pulled from the database, or whether that's taking a particular part of a link query and translating it to SQL. We have literally hundreds of services that make up EF now. And there's two main scenarios I wanted to look at. One is sometimes you want to pull out a piece of EF and reuse it. So one example is maybe I have a part of my stack where I'm bypassing EF and I want to drop down and work straight with the database. And I would like to know some of the type mapping. So if EF has a string property, I could write code to say string maps to nvarchar max, but maybe I want to use the EF component that can tell me the default type mappings it uses. So that was a quick example we were going to look at here.
So it's a little bit of mix and match while still collaborating or cooperating with EF when you kind of drop out. Is that the way to think of it?
Yeah, and I would say the more common scenario that we're going to look at in a second is actually replacing or tweaking those services. But we do from time to time have someone that's like, how do I use your convention that works out table names? Because I would really like to use that for a separate piece of code that I have in my project.
Oh, I see. That's different. That's more like EF being composed of services and you get to cherry pick which ones that you want to use.
Yeah, you might have a particular requirement in your app where you're not using EF, but you want to use a piece of the functionality that EF has.
Nice. Yep. I like that.
Okay, so the type mapper is one example I like to pick on. So to get our services, we need to get a service provider, and we kind of hide that away because not everybody wants to drop down and muck around with services and service providers and all those things. We have a get infrastructure method, which is a kind of a generic piece that says, give me this thing that EF is hiding, but I can get to it. It's kind of the idea of, also it could be done as explicitly implementing an interface where you have to cast to the interface to get the thing that it's hiding. So I can say, get me the underlying infrastructure and I want the iService provider. Service provider it's basically a collection of services. It follows a dependency injection pattern, and that's actually how EF works internally. Not that you really need to know that, but internally we use dependency injection. So we say, these are all the things that EF wants to use, and then some of those things can depend on the other things, and dependency injection takes care of making sure each component has the other components it uses. So the service provider is just that big collection of services, and so we could get a mapper from it. So we could say service provider.getService, and we might want to say, get me the iRelational type mapper.
I thought you were going to write Ireland there for a little bit.
Not quite. I don't think we have that service just yet. Okay, so that gives us a type mapper. Now there's actually a shortcut I can do here. I can actually get this directly off the context. I wanted to split it out into separate calls first, just to help folks understand that we get the service provider and then resolve the service from the provider. But we created a shortcut on the context, which is get service, which does those two steps for me. So I can shortcut this and say, get me the iRelational type mapper that's currently in use. Currently in use is important because my context might be set up to hook up to Oracle and to SQL Server. And so by saying, give me the iRelational type mapper, I'm saying, whatever relational type mapper is in use at the moment, give me that one. Which in our case is always going to be SQL Server because that's what this model is hooked up to.
It's kind of like asking for the culture of the current thread.
Exactly, yeah. So we'll get the mapper, we'll get the type off it, and just write the name out. So this will tell us what type it is. It's not going to be obviously an interface, it's going to be an implementation of that interface. And then let's use it to so we'll say find mapping, and we want a mapping for the type of string.
Love interpolated strings.
Yeah, I was going to say this is where we insert a plug for string interpolation,
Oh,
right?
It's one of my favorite features.
And store type will give us the database type. So we're saying to the mapper, give me the mapping that you would use by default for a string property, and then give me the underlying store type. And well, actually we want a bool in this one, so let's do bool instead of string, and string is interesting, so let's do that too. All right, so let's run the app. And we'll see that the type mapper in use is the SQL Server type mapper. No surprise, because I'm hooked up to a SQL Server database. Bool is mapped to bit in the database, and string by default is mapped to nvarchar max.
Got it.
So if I had a piece of my app where I wanted to do something like this, I could reuse this service to do it. Let's go a little bit more interesting though. What if I wanted to customize the type mapper?
One question about that is, you said that when you moved from regular EF to EF Core, you moved from monolithic to modular.
Mm-hmm.
So this particular functionality is quite narrow in nature. So how much of EF Core am I going to fault into my app? Obviously my desire would be like, oh, I just want that like little bit of code. I don't want to, fault in all this stuff. Can you speak to that?
If you're using the SQL Server type mapper, it means you have the SQL Server provider installed. So at that point, you have quite a bit of EF in your app. EF Core itself, at the heart of it, has no relational concepts in it. So perhaps another way to slice it, if I'm targeting something that's not a relational database, say Azure Table Storage, then the relational parts are not, those assemblies aren't even, the packages aren't installed in my project at all. But once you pull in a part of the runtime, you get the whole runtime, if that makes sense. So if I'm using a part of SQL Server, then I have all of the SQL Server runtime. Where we split is down the tooling. So if I have components in my app that are used specifically for tooling, migrations is a good example, or reverse engineering from an existing database, then those components only exist if I actually want to use the tools. I specifically go and I install the SQL Server tools package, or it's actually the SQL Server design package that has the hooks for the tools to use. And so I only have to put that in my app if I actually want to use it.
Got it.
So
in this particular case, since you're talking to SQL, you actually would have faulted in a fair bit of EF Core.
Yeah.
But if you had gone down this Azure table route, just based on the way EF Core is built, that one would be a bit more minimal.
Yeah, so I wouldn't have the base relational provider. I obviously wouldn't have SQL Server, Oracle, or MySQL or anything installed, and I wouldn't have installed any of the tooling either, unless I needed tooling.
Got it.
Yeah. So using it is interesting, but that probably applies to less folks. The more common thing is going to be I want to tweak the implementations, and we've made an effort to factor these things so that you're not forced with replacing the service. You can actually take our service and tweak aspects of it. And we try to factor things that make common tasks easy to override. So you're not going to GitHub and copying all of our code and tweaking the bit that you want to.
Yep.
Let's swap to the replacing services one I have here. If we look down at my blog class here, you'll see I've added an XML attribute. This is just an attribute that I put in my project. It's some arbitrary thing I came up with. And I put it on a string property here. And what I'm saying here is this is a string in my model, but I want it to, in SQL Server, I want you to make it an XML column in the database. I've derived from the SQL Server type mapper that we just saw, and called it custom SQL Server type mapper, and I've overridden the find mapping method. I'm just going to collapse Solution Explorer to give us a bit more room. And I'm going to write an if block here. So I'm going to say if this has the CLR attribute, the XML attribute, that's a helper method that I wrote. I'll just, for the sake of transparency, go and show you what it does. It's looking at our metadata in EF and then looking at the CLR metadata and working out whether this attribute is present on the CLR class. I'm not going to dig super much into the implementation of that. If it has the method on it, then I just want to return this type mapping that I have up here, XML. You can see we have the concept of a relational type mapping that says this is type name in the database, this is the type in the CLR, this is the ADO.NET type. Obviously we're in relational specific things here, so it's the ADO.NET DB type. And so if the property has that, return it. If it doesn't, just fall back to the base implementation. And then similarly, there's another, the inverse of that is find the mapping based on the type name. And so I've just said the same thing. If the type name is XML, then spit it back out. Now we need to get this service into EF. Now in 1.0, this was really complicated. If I wanted to replace the services, I had to take over constructing the service provider, which meant creating a service collection and adding all of the default services to it, and then adding the one that I want to add, and I have to make sure that I give it the right scope in dependency injection. It's really complicated, and it messes up my app a lot. In EF 1.1, we've introduced a new method, which makes things a lot easier. So in onConfiguring, I do options builder.replace service, and I want to replace the SQL Server type mapper with my custom SQL Server type mapper. And EF will take care of doing all the work under the covers to get that thing into dependency injection.
Right, so you would do that on the scope of the app, meaning if in different parts of your app you want to do that same kind of thing as you did with that one property, then you would do it all in that one place.
So onConfiguring is a method on my context, and this gets run every time we create the context. So I can say when you run this, obviously I could pass in constructor parameters or something like that that says when I pass in a bool that says connect to SQL Server or SQLite, and I could switch on it here and use different connection strings. Now, if the same services are registered, then we don't create a new service provider on each one. We basically cache these things so that if the same services are there, we just reuse the existing service provider. Same thing too, if we're hooking up to the same database, then we use the same model that we previously built for that database. So we're pretty efficient, but these things run effectively every time that the context is created. So I can have different instances of the same context with different setup. If I'm writing an ASP.NET Core application, this stuff actually goes in startup.cs instead of here in line, and it gets passed in because ASP.NET has dependency injection built in, so all this stuff gets passed into my context externally.
Yep.
Cool. Okay, if we go look at what I've written here, I've got the same code that we just wrote in our other app. We get the iRelational type mapper, we get the name of it, and we get what types it would map to by default. And then I go and I recreate the database based on the current model. Obviously, this method of creating databases is good for demos and prototyping and stuff. This isn't what you do in a production application, of course, but for demo purposes, it works well.
Yes. Reminds me of Tommy Drop Tables.
I don't know that one.
Isn't that the guy's name? Or that's the XKCD cartoon.
Oh, okay.
Oh, so that his name is actually an exploit?
Yes.
Mm.
You haven't seen that one before?
I've seen people use SQL injection in license plates.
Oh, that's fantastic. I mean, that's horrible.
Of course. Yeah.
So we can see here that our custom SQL Server type mapper is in use. None of the default mappings have changed. So a Boolean property still maps to bit, a string still maps to nvarchar max. We didn't implement any of that. We just used the base implementation. But if we go and look at our database, and I'll just refresh so that we get the new database that was created. Replacing services. And I'll select the data from this table. We'll see that the data for metadata is getting written into an XML column. So we were able to replace the type mapper and tweak its implementation. Now, I do just want to call out, you can't. We mentioned before that doing simple type conversion is a feature that we're working on. So the reason I can do this type conversion from string to XML is because ADO.NET takes care of that for me. It's quite happy to say, oh, I have a string value coming in, I know how to stuff that into an XML column. If I wanted to do something more complicated, like having a string in the database that's actually mapped as a bool in my model, I can't do that yet. That would require the feature we're working on at the moment called simple type conversion.
Well, you have to actually implement the code to...
Yeah, I think the way that we're going to implement that is, well, you write a piece of code that says, this is how it comes from the database, this is how it is in my model. You write a piece of code that tells us how to do the mapping.
In both directions.
Both directions, yeah. And that's actually a similar feature that will allow us to do mapping directly to methods, get and set methods, instead of using a backing field. You can tell us, given this data, this is how you get it into my object. Yep.
Yep.
Cool.
Makes sense.
All right, let's do one more demo. Full Solution Explorer back. One of the things we try to do in our providers is surface the features that make sense for that provider. So this is actually a deviation from EF6. In EF6, everything was baked into the core. And so if you had a feature that some providers or even one provider supported, you had to go and bake that into the core. So one example would be spatial data types. There are some database providers that support it and some that don't, but we had to put it right into the core of EF. And more than that, we forced everyone to use our implementation. So we had DB geography and DB geometry, and you had to use those as your spatial data types. In EF core, we want to make it not just so that if you target Azure Table Storage, you don't get relational stuff. But if you're targeting SQL Server, we can start to light up SQL Server specific features. The same way too, if we're looking at Postgres, Postgres has particular spatial implementations that it would be great to use their native ones that they have built in without having SQL Server have to use the same thing. And so we're trying to let providers light up features. One example of that we did in 1.1, SQL 2016 has the idea of a memory optimized table. So we wanted to light up support for that in Entity Framework. And obviously this goes in the SQL Server provider because it's specific to SQL Server.
Makes total sense.
So I have a demo project here, which I'll just walk you through quickly. This is built around the idea of having a set of sensors. And a sensor would be something like a temperature sensor or a humidity sensor. And it's going to spit back reads that it does in sequence. So it's going to say, I read the temperature, it's 32 degrees, now it's 32.5, now it's 32.75. And it's going to spit those back to us in this object here, which is what we're going to map and save to the database. A couple of things to look at.
That'd be Celsius, of course, right?
Yeah. Hopefully. I'd much rather be in.
Yeah.
Kelvin for the win.
Yeah.
I was trying to pick a value that actually worked for both.
Yes. So. Well, so the three of us grew up in countries that use Celsius, so that's the joke.
None of us use Kelvin, though, I assume.
Everybody should.
Yes. Okay. Okay.
It's the only one that makes physical sense.
Moving right along.
Okay.
Okay. So, a couple of things to note about this data. It's heavily indexed, for one thing. You can see I've got a whole bunch of indexes on it here. And then if we scroll up to the actual implementation of my app, we're spinning up a whole bunch of threads. I think there's 10 of them here that are going to mimic monitoring 10 different sensors and just spewing a whole bunch of data coming back from those sensors into the database. So highly concurrent and heavily indexed. If we just go and quickly look at what one of these monitor sensor things does, it goes, obviously we're using some fake data because I don't have a whole bunch of sensors hanging off my laptop at the moment, so we create 100 fake records, we go and save those to the database, and then we pull back a set of data from the database.
I just saw, I take it in a real app, you wouldn't still be using your blogging context in a sensor app.
Probably not.
Yeah.
I should change that in this demo.
Yes, that part looks a little odd.
Yeah. So we'll call this sensor context instead.
Yeah.
Okay.
That was just a code review.
Very good.
Yeah.
Now you've thrown me off.
Totally.
Carry on. All right, so highly concurrent, very heavily indexed, and the concurrency is all around the head of the table. So we're inserting a lot of data and then we're selecting back from that head of the table. Let's run the app at the moment. At the moment, I'm just using the default database that EF is going to create for me, which has nothing to do with memory optimized tables. We'll start up our 10 worker threads, and then I have a separate thread that's going through and monitoring how many requests per second we're getting in the database. And what we'll see is this will ramp up for a little bit and then it will flatten out. Yeah, we're seeing it to flatten out now. So we're getting 300 to 320, it's just say 320 to 330 actually, requests per second with the default tables that we get, which would be standard disk-based tables in SQL Server. This would be a good scenario for memory optimized tables because the description of the scenario is exactly what memory optimized tables are designed for. So in on-model creating, I'm going to add some code here. We're going to say model builder. We're going to pull up the configuration for the sensor read object. And then I'm going to call a method for SQL Server. So anything that is provider specific starts with the for SQL Server. So it could be
or whoever the provider is.
Yeah, exactly. So if I'm mapping a table, I can actually do different tables for different providers. So I could say for SQL Server, the table name's this, and for Oracle, it's this. So I'm saying for SQL Server, use a memory optimized table.
So even though it looked like your connection string before said something about memory optimized in it, if I saw it correctly.
Yeah, let's go up and look at that. So that's just what I'm calling the database.
Ah,
That's the name of the database. I guess the other thing to note, I am hooked up to a SQL 2016 instance. My
I see.
previous version of LocalDB I have on the box doesn't have memory optimized tables in it, so I've got SQL 2016 specifically installed on my machine.
Right. So the method call that you just made is really the first point at where you're suggesting to SQL to use memory optimized memory optimized tables.
Yeah, and actually the way this is implemented, so we tried to make our core metadata model very extensible, and so we have the idea of annotations. And so the SQL Server provider is dropping an annotation onto this entity type saying, here's a hint that this should be a memory optimized table when it's SQL Server. So if I also hook up to Oracle, it's going to ignore that annotation, but the SQL Server provider is going to pick it up and treat it as a memory optimized table.
Yeah.
If I go run this again, because we're allowing EF to create the database for us, it's going to drop and recreate the database. This time it's going to create a memory optimized table for us. And what we'll see when it ramps up, we get quite a few more requests per second through. Now, it's a decent increase here, but it's not like the 10 or even 100-fold that we see in some of the demos of memory optimized. And that's because I'm running on a laptop with 2 physical cores. So on a real server, we would see significantly bigger increase than this. But on my disk-bound, memory-bound, CPU-bound laptop, we see an increase that's more modest.
Mm-hmm.
The key takeaway from this, though, is we're making it easy for folks to use provider-specific features. So I didn't need to really know a huge amount about memory optimized tables to be able to set up my model to use it.
Right. Makes sense.
Okay. All right, I'm sure we're going to wrap up with a few questions. While we do that, I'm just going to pop these links up on the screen so that folks can head to. So the first one is our documentation, which will tell you everything you need to know about using EF Core. The second one is our GitHub project, which is where you can go to file issues, look at contributing, etc. And then the last one is my GitHub repo where I put the demo source code. So you can go and grab the source code I showed you today.
Excellent. Thanks. That was awesome.
No problem. Happy to be here.
Totally. I actually just have one
Go for it.
follow-up question and then an announcement,
Yep.
if I have time for that.
Yep.
So on the question side, back to the transition and focus from relational to non-relational, as you say. What does that look like in the context of universities? So do you know, I assume, 10 years ago, all they were teaching was relational. When I went through university, that's all we learned about. I don't think they even touched on this concept.
Mm-hmm.
Do you know what they're teaching kids today on the database side?
So it was the same for me when I went through university, which was a little over 10 years ago. It was the same. It was all relational databases. I think that's changing now. It probably depends a lot on where you go. I mean, we know that the tools you pick vary a lot from university to university. Some folks come out knowing .NET, a lot of folks don't. So, but yes, in general, from my perspective, I would say right across the board, we're seeing folks learn more and more, not just at university, but I guess anywhere you get educated.
I wonder if our friend Kendra has
I
an
was actually just
opinion
thinking that
on
we
this.
might have someone here who knows this.
We definitely did relational in my database class, but I did not get to the advanced database class. So maybe it's in there at OU.
What about I know at the university I went to, they didn't do this when I was there 100 years ago, but they now do like a ton of hackathons. And I think this is a pretty common trend at universities where there's multiple hackathons a year, either sponsored by the school or often actually sponsored by businesses. Someone like Microsoft will go into there or Google or whomever, and it's like, oh, we'll do this hackathon. And so I'm wondering, even if they don't teach it in the classes, if that's part of what students talk about on campus at the hackathons or otherwise. Anyone have any thoughts about that?
I mean, I'm guessing it would be just, in general, there tends to be a buzz around certain technologies.
Don't look at me. Computers
Yeah.
hardly existed when
Yeah.
I went to the university.
Yeah.
I mean, in general, right, we see buzzes come around with computers,
Yeah.
and I would say at the moment, there's definitely been a buzz for the last little bit around the idea of having more choices than just a relational database. So I would say it's probably hard-pressed to find someone in the computing industry who hasn't at least given some thought to non-relational databases. The statistics probably change when we actually talk about people who have used them, because I would say a lot of folks are still sticking, when it comes time to write a real production application in an enterprise, the focus is always on getting the job done. And so if I don't know how to use a non-relational database, the idea of going and taking the time to work out how to use it
Totally.
isn't necessarily going to outweigh the benefit.
Totally.
Mm-hmm.
Any more thoughts on that, Kendra? Were there hackathons at your school?
Yeah, there definitely were, and there were always a lot of different buzzwords that people would use. So, yeah.
So yes,
Yeah, I think it was probably one.
makes sense.
Okay, announcements.
Yeah, so super small one. We last month we released the September updates for .NET Core. We had a blog post on that, and that was the 1.01 release. Today we put out another blog post for the October updates for .NET Core. So that's actually 1.0.2. This one is significantly less of a big deal than the last one. It's actually one fix, a singular fix, only on Mac. So we saw that if you did clean installs on Mac OS Sierra, that the .NET tool didn't work properly. In fact, it wasn't even findable because the bug is that it wasn't showing up in the path.
That fix.
Yes, that singular fix. It turns out if you actually had it working already and you upgraded from El Capitan or an earlier macOS version to macOS Sierra, then you were good to go.
So you don't really need to know about this update or
Right,
apply it
yeah,
necessarily.
yeah. So if you have a working system and you already had 1.0.1,
You
then
don't need to bother. with
you
it.
don't need to bother. This is solely for people building up new machines from scratch. If you've never installed .NET Core on your Mac
On a Mac.
machine and you're already at Sierra, then you would need this. We've updated the Mac installer on our download
Yeah, it was
page.
just an environment variable.
Yeah,
or
so-
something on the path missing.
Right, so this will just happen naturally. The only reason I'm really bringing it up is just to help people understand
Sure.
what this even is. So the Windows and Linux releases are still at the 1.0.1 level. There's no 1.0.2 release for them. When we release again, then it'll be 1.0.3. The Windows and Mac releases will never have a 1.0.2 release. They'll skip that. So hopefully that provides people with insight. So thanks for everyone who reported that issue. It's fixed. We can I'll move on with life now.
Yeah, and we had another blog post yesterday on the new tooling for .NET Core. It's an interesting post to see where things are going in terms of building a .NET Core application. So definitely check out this blog post. And there is a good comment thread on
Yeah, I noticed that.
that we're looking at and trying to answer the comments as they come in.
Yeah, when I went to bed last night, there was something like, give or take, 20 comments. When I woke up this morning, there was almost 70. And by the time I got to work, there was over 100. So it's
people care.
yeah, people care. So It seems like that would be a good topic for the show at some point. Are we gonna have someone
Yes,
on the show?
we are. Yeah.
Okay. Unscheduled still?
I think
or-
it's next week.
Okay.
Actually.
That would be a good idea.
Yeah, it was last week's show actually, and we had to cancel because the blog post wasn't ready.
Yes.
Yeah, full
Oh, yeah.
transparency here.
Yes.
So yeah, that's what happened.
Yeah, and that's my fault. So
No, it's not. Not only.
yeah, it's just partially.
And okay, so for full disclosure, we did have some technical issues today as well.
Yes.
Right.
Our choice was either to stop and reboot so that we could do the stream or just record.
So we chose to just
Record.
not interrupt you and let you carry on with the
Okay.
show.
Okay.
So this hasn't been live. We are making sure that the video is available today. And apologies for people who wanted to ask questions live. Those things happen. We are trying to minimize them. So,
Okay.
well,
So Rowan and I didn't have to feel quite as much pressure on our shoulders due to the liveness.
yeah.
It
So
wasn't-
if you noticed us being a little stressed out at the beginning of the show, that was
Yeah.
what was happening.
So
That's why I
you
had
enjoyed
to
the
run
edited
out.
version of this video.
Yes,
couple of hours.
and hopefully not too many doors closing and opening.
Mhm.
So yeah,
Okay, makes sense. Well, this was
All right.
awesome.
Thank you.
yeah. Thanks,
good.
thanks
Yeah,
for
thank
being on
you
the
a
show
bunch.
again. It's always very interesting, and I hope we have you again
Mhm.
next time we have something to show people.
Sounds good.
Excellent.
Thank you.
Thanks
Okay.
again. Thanks, Kendra. Thanks, Rich.
Yeah,
Thanks, Rowan.
no problem.
And we'll see you again next week. Bye.
Yeah. Bye.